Our paper introduces the ability to edit the BRDFs of objects while interactively rendering the scene with global illumination. Here we show a live screen capture of our material editing system. This Cornell box scene is rendered with an area light source and 4 bounces of global illumination. We start by showing a simple edit where we change the color of the small box to yellow. We do this using the parametric controls as seen in the top right window. Notice the strong interaction between the red light coming off the left wall as it illuminates the side of the yellow box. If we turn off global illumination, many important visual effects are lost and we are not able to make informed choices when editing an object's material. When we turn global illumination back on, the left side of the box is no longer in complete shadow. In addition, as we try out a greener shade for the box, we can see how other objects are affected by our choice of BRDF. For instance, the top of the green box, which is not even directly visible, produces a strong color bleeding effect onto the ceiling. As we continue to edit the small box, the changing appearance of the box also updates in the glossy reflection of the floor. We will now perform a more complex edit on the floor's BRDF using the curve shown in the bottom right. This 1D function controls the BRDF's behavior along the theta-half parameterization. The shape of the peak near theta-half equals 0 controls the specular falloff. We widen or narrow the peak to explore possible degrees of specularity for the floor, noting how the appearance of reflections changes as we make our edit. We now show an interior design session for a complex indoor setting. The only light source for this scene is the light allowed to enter from the environment map outside through the windows. Even though no artificial lights are present, the ceiling still has a strong influence on the appearance of the room. By editing the color of the ceiling, we can change the mood of the lighting in this room. After noting the global effect of a bluer ceiling on the staircase and couch, we instead choose a yellow color to complement the mostly yellow light coming in through the windows. The couch's red fabric BRDF creates a strong color bleeding effect onto the wall and stairs behind it. The couch's measured BRDF comes from the Matusik database, and we can edit it non-parametrically using the curve seen here. Notice the change in reflected light onto the staircase as we amplify the peak of the green component. We leave the tail behavior of the curve unchanged to preserve some of the original red tint. Next, we experiment with different material properties for the floor. We load in a new set of textures for BRDFs of the floor to model Spanish tiles. The floor is composed of a diffuse and specular layer, each of which can be textured separately to produce the spatially varying BRDF seen here. We now remove the diffuse component to highlight the performance of our system even in the presence of near-mirror BRDFs. When we narrow the slope of the distribution for the Cook-Torrance BRDF of the tiles, we can see reflections of other objects in the floor. Our standard approximation is such that objects appear to be diffuse when viewed through reflections. Unless the reflected object is extremely specular, this is a very reasonable approximation. If we turn off global illumination, we can see that large portions of the couch and shelves are exclusively lit by indirect lighting. Furthermore, when we turn global illumination back on, the indirect lighting is visible in the glossy reflection of the floor. This effect requires at least a 3-bounce simulation. We conclude our editing session by bringing back the diffuse component for the floor's BRDF. This scene shows a ring on a ground plane in complex lighting. As we increase the specularity of the ring, its concave shape focuses the light into caustic patterns. This is a complex secondary effect that requires a version of our framework that uses 16 bases to represent the BRDF for second bounce interactions. The pink and blue caustics result from bright areas in this environment map from inside St. Peter's Cathedral. The yellow caustic is a result of a small local area light source that we have added to this scene. As we now also make the ground plane more shiny, we can see interesting interactions between the focused caustic energy and the reflective nature of the plane leading to the arc seen here. As we continue to increase the exponent of the ground plane, the reflection of the ring becomes sharper, and the ring itself updates as we alter the way light reflects off the plane and onto the inside surface. If we look at this scene without global illumination, we notice that it is difficult to tell if the ground plane is matte or shiny. Our system correctly renders the higher order effects that are integral to material perception. In summary, our work introduces the ability to interactively edit BRDFs in global illumination. We reduce the problem's complexity by leveraging the low-frequency nature of indirect lighting. Our system precomputes a polynomial representation of the image offline and then evaluates it in a 2-step runtime process that enables us to achieve interactive rates as seen in this video.